Before the light, there is the dark, a deep, cold, and patient dark, adrift between the stars. This is a molecular cloud, a stellar nursery. It is a vast, ethereal continent of hydrogen gas and microscopic dust, unimaginably vast and colder than anything we can truly conceive. It is a place of potential, a place of waiting. For millions of years it simply drifts. Its own gravity is too weak, too diffuse to pull it together. Its atoms are in a state of quiet, slow motion ballet, a dance without a conductor. It is a promise, unfulfilled. Then something changes. From a great distance, a ripple arrives. It is a shock wave, the ghost of a star that died a glorious death long ago. The supernova's final, expanding breath washes over this cloud. It is not a violent impact, but a gentle cosmic push. A whisper of compression. It is the trigger, the catalyst, the first domino to fall in a chain of creation that will span billions of years. Gravity, which was once too weak, now has a foothold. The regions compressed by the shockwave are now dense enough to begin calling to themselves. The quiet ballet ends. A new movement begins. It is the slow, inexorable process of collapse. It begins to fall, not in the way a stone falls, but in a way that is far more grand and deliberate. The cloud begins to fall inwards towards 100 or 1,000 different centers of gravity. We will follow just one. A knot of gas and dust, trillions of miles across, begins to contract. It is a process of immense patience. Over thousands of years, the atoms and molecules drift closer, their random paths slowly bending into a shared journey towards a common center. As the cloud shrinks, it begins to spin slowly at first, then faster like a skater pulling in their arms. It flattens into a vast, rotating disk, a protostellar disk with a growing, hungry heart. At the center of this spinning disk, the material is densest. The pressure builds. The atoms are crushed together, and as they release energy. A faint, dull, red glow begins to emanate from the core. This is not yet a star. It is a protostar, an infant, a warm, glowing embryo cocooned within its dusty placenta. It is the universe's first hint of the fire to come. For 100,000 years it grows. It feeds on the gas and dust from the surrounded disk, pulling in streamers of matter, growing more massive, hotter, and denser with every passing moment. The pressure at its core becomes unimaginable, the temperature rising from hundreds to thousands to millions of degrees. And then the moment arrives, the point of ignition, at 15 million degrees. A threshold is crossed. The pressure is so immense that the very nature of matter is overcome. 4 hydrogen atoms, the simplest elements in the universe, are crushed together with such force that they fuse. They merge, they become a single atom of helium. And in that tiny, miraculous act of transformation, a small amount of their mass is not preserved. It is converted into pure energy. A pulse of light, of gamma rays and neutrinos, is born in the heart of the protostar. It is the star's first breath. Its first heartbeat. The fire is lit. A star is born. Immediately, a new balance is found. The outward pressure of this new, ferocious energy pushes against the inward crush of gravity. The collapse is halted. The star settles into a state of perfect, elegant equilibrium, a cosmic truce between 2 fundamental forces. It enters the main sequence, the long and stable adulthood, that will define the vast majority of its life. For the next 10 billion years, it will be a beacon of stability. Its life is a quiet, continuous song of nuclear fusion. In its core, every second, it converts 600 million tons of hydrogen into helium. This is its work, its purpose. The energy from this fusion begins its own long journey. A single photon of light born in the core does not fly straight out. It is absorbed by an atom, then re-emitted in a random direction, only to be absorbed and re-emitted again. It stumbles through the dense plasma of the star's interior in a journey that can take 100,000 years. A journey from the heart to the surface. And when it finally breaks free, it streams out into the void, a particle of light carrying a message from a star's deep past. It travels across the disk of gas and dust that still surrounds the young star. In that disk, planets are forming. The light from the star warms them, shapes them, and perhaps on one of them, provides the energy for life to begin. The star does not know this. It simply shines. It is a constant, a provider, a source of unwavering light and warmth in its corner of the galaxy. An eon passes. Planets complete billions of orbits. On one of them, mountains rise and fall. Oceans form and shift, and tiny, conscious beings emerge who look up at their parent star and give it a name. The star knows nothing of this either. It continues its song, its slow and steady conversion of hydrogen into helium, the same work it has been doing for ages. But nothing, not even a star, can burn forever. The fuel is finite. After 10 billion years of faithful service, a change begins in its core. The vast reserves of hydrogen are running low. The furnace begins to sputter. The balance is broken. With less energy pushing outwards from the core, gravity begins to win the long-held truce. The helium-rich core begins to contract and heat up even further. But this contraction creates a new wave of heat that pushes on the layers above it, where there is still fresh hydrogen. This outer shell of hydrogen ignites in a furious, desperate burn. This new intense energy pushes the star's outer layers outwards, dramatically. The star begins to swell. It grows larger and larger still, expanding to 100 times its original size, engulfing its inner planets. As its surface expands, it cools, and its color changes from a brilliant yellow-white to a deep, luminous and somber red. It has become a red giant. It is the star's old age, a final, grand, and beautiful exhalation. For a time it shines as this luminous ghost of its former self. In its superheated core, a new miracle begins. The helium ash, the product of 10 billion years of fusion, is itself ignited. Helium atoms begin to fuse into carbon and oxygen. The star has learned a new trick, a new way to hold back the darkness. But this is a short-lived reprieve. The helium burns fiercely and is exhausted in a mere fraction of the star's former life. And then the end comes. Not with a bang, but with a sigh. The fuel is gone. The fires in the core die out. For good, the outward pressure ceases. Gravity, patient and relentless, wins the final victory. The core collapses under its own immense weight, crushing itself down into an object the size of a small planet, an Earth-sized ball of superdense carbon and oxygen. At the same time, the star's outer layers, the red, gaseous envelope, are no longer held by the core's powerful gravity. They begin to drift away from the dying star. In a series of gentle, slow-motion pulses, the star sheds its skin. This expanding cloud of gas is ionized by the intense radiation from the exposed core, and it begins to glow with breathtaking, intricate colors. It forms a celestial smoke ring, a cosmic ghost, a structure we call a planetary nebula. It is the star's final beautiful act, a gentle release of its substance back into the cosmos. And at the center of this fading, dissolving jewel lies the remnant. The core. It is now a white dwarf. It no longer generates new energy. It is a stellar ember, glowing with the residual heat of a 10 billion year life. It is incredibly dense. A teaspoon of its matter would weigh many tons. It is a diamond in the sky made of the very stuff of life, and it is slowly cooling. Over trillions of years, longer than the current age of the universe, its light will fade from white to yellow to red, until it becomes a black dwarf, a cold, dead cinder, adrift and invisible in the final, dark night. This was the gentle path, the quiet death of a star like our sun. But for stars born with much more mass, the story is faster, more violent, and far more spectacular. A massive star lives its life in the fast lane. It burns through its hydrogen in a mere few million years. Its core is so hot, so dense, that when the helium runs out, it does not die. It continues to fuse heavier elements. Carbon fuses into neon, neon into oxygen, oxygen into silicon, and finally silicon into iron. Iron is the end of the road. Fusing iron does not release energy. It consumes it. The star has created a core of pure iron ash, and in doing so, it has signed its own death warrant. In less than a second, the balance is not just broken, it is annihilated. The core, with no energy to support it, collapses catastrophically. In a fraction of a second, an iron core the size of the Earth crushes down to a ball of neutrons just a dozen miles across. The outer layers of the star, which were once falling inwards, now slam into this newly formed, incredibly dense neutron core. They rebound. The collision creates a shockwave of unimaginable power, and it begins to tear the star apart. This shockwave, combined with a furious blast of neutrinos from the core, is the most powerful explosion the universe has to offer. It is a supernova. In a single, silent shout of light, the star becomes brighter than 1 billion suns. It outshines its entire host galaxy. For a few brilliant weeks, it is a beacon visible across the universe. In that final, glorious act of destruction, it does something profound. The energy of the explosion forges all the elements heavier than iron, the silver, the gold, the platinum, the uranium. The star does not die. It gives itself away. It blasts its outer layers, enriched with all the carbon, oxygen, iron, and gold. It has spent its life creating out into interstellar space. This stardust, this precious material, will travel across the void. It will seed other molecular clouds, and in the place where the great star once shone, a remnant is left. Perhaps a neutron star, the densest object in the universe, spinning hundreds of times a second, a cosmic lighthouse. Or, if the star was massive enough, gravity wins completely, and nothing can stop the final collapse. It creates a black hole, a point of infinite density, a place where gravity is so strong that not even light can escape, a perfect silence. But the story does not end in silence. It ends where it began, in the cold, dark, and patient space between the stars. The enriched gas from the supernova mingles with a vast cloud of hydrogen. The cycle begins anew, but this time the cloud is different. It contains the legacy of the star that died. It contains the carbon needed for life, the oxygen needed for water, the iron needed for blood. The next generation of stars will be born from this material. The next generation of planets will form from it, and perhaps on one of those new planets, life will begin, looking up at its star, unaware that it is made of the ashes of a star that died long ago. The end of one story is always the beginning of another.